Okay, so in this video, we will talk about how to implement the test workflow with TestChimp. So one of the good things with having your user stories and scenarios as markdown files is that you can simply drag and drop those files into Cursor or Claude and then ask it to implement the user story. So in this video, we will focus on the refund capability that we are adding to the Milliways sample app. So once the PR is done, you can simply invoke our skill and say test, and it will execute the entire testing workflow, which will consist of multiple phases. The first phase is it will create a detailed plan of the testing it will do, and it will present to you the plan and ask for approval. All right, so let's take a look at the plan it has generated. So the first thing you see is that it has identified the relevant user stories and what are the scenarios of that scenario user story that is relevant for this PR. And then it identifies the tests that it needs to write. So it has identified the refund button enabled for recent orders. The refund button should show a confirmation upon request and so on. And then for each test it plans to author, it identifies what arrangement steps needs to be done, such as fixtures that needs to be added, seed endpoints that needs to be authored, and any mocks and etc. And what are the actions that needs to be done on the test, and what needs to be asserted. So it can be UI validations or it can be backend validations. And if it is backend validations, it will identify if any probing endpoints need to be authored and so on. And it will do this for each of the tests that it identified to be authored in this testing workflow. And then it goes into identifying any system infrastructure updates that needs to be done, such as seed endpoints, probe endpoints, true coverage instrumentation, which we will touch upon on a separate video. And it also identifies the regression test that needs to be done. So these are existing tests that might be affected by this PR. And as part of the testing process, it will execute those tests. This allows to identify regressions without having to run the entire test suite, which can be quite slow with large test suites. And finally, it will do an TestChimp run on the new tests as well as the updated existing tests. So TestChimp will walk through your application guided by those tests and identify various UX bugs by analyzing screenshots, DOM, the console logs, network activity, and browser metrics. So now it goes on to write the tests after we gave the approval for the plan. And now you can see it executes those tests that it authored. And one of the things you'd see is that the test user that was created was not a shared one, but one that was created specifically for that test. We will get into more details around that when we talk about how the seeds and fixtures come into play. Okay, so now let's see how the execution step is done gets reported in TestChimp and how you can view them. So the first surface is the tests page, where you can go to the Insights tab and select execution history. And you will see all of the test executions that was done for that branch. The more interesting one is when you go to the plans page and go to the Insights tab, you can see the executions linked to the requirements, the user stories and scenarios that they executed. So you can see over here how the refund related tests that we executed is linked to the scenarios that they correspond to. So you can see which scenarios are covered and which scenarios are not covered. And the nice thing with storing your user stories and scenarios as files in folder structures is that you can zoom into any folder level and your requirement coverage information would be narrowed down to that scope. So this allows for large teams with multiple areas that they work on to focus on the areas of interest for them. And you can see other insights like trends, as well as exploratory bugs that was found by TestChimp. An interesting thing with the way we work with TestChimp is that they run based off of the tests. So the same traceability extends to the UX bugs that is found by TestChimp. So you can see the various different types of UX issues that it identified by analyzing the screens, and you can dig deeper into viewing each of those bugs. So when you select a bug, you can see where exactly these issues are happening. And this page is called Atlas, and it shows on the left-hand side your app structure. You can see the various different screens and the different states of each of those screens automatically identified, and the bugs attached to them. And we will later on go into details on how exactly we enable this in the way we write the tests. All right, so let's take a look at those tests that was authored. So the first thing you'll notice is that those tests are written in Playwright style and not Selenium or Appium style that is common with mobile application testing. This is enabled by us using MobileWrite as the framework, which is built on top of Playwright and gives you asynchronous execution and auto waits that removes a lot of flakiness that is common with Appium-based testing. The second thing you'll notice is these @scenario links at the top of each test. So these allow to link the test to the scenario that it covers without the need for separate Excel sheets that are maintained manually and uploaded to third-party vendors to get the requirement traceability that you saw earlier. And because these are directly written inside the test code, agents can easily author them while they are authoring the test itself. Another reason why tests become flaky with end-to-end tests is that usually you would reuse the same test entities across tests, and this causes interdependency between tests and interdependency between test execution attempts as well. But when TestChimp authors tests, it uses fixtures in the proper Playwright guidance way by using this test info object that is provided by Playwright and creates test entities that is scoped for each individual test run. So this makes each of those tests idempotent and independent from any other test executions, and they are suitable to be executed by parallel runners in Playwright. Remember how in Atlas page you saw bugs attached to different screens? This is enabled by a special fixture that is built by TestChimp that is used in these tests. So how that works is when Cursor is authoring your tests, it will identify when screen states change in the app, and it will add these mark screen state steps with the screen and the state name. The vocabulary of these are maintained in TestChimp platform and communicated with your agent to make sure that the vocabulary is consistent. And when TestChimp walks through your app guided by these tests, it will use those mark screen state steps as anchor points to then go ahead and analyze the screenshot, the DOM, the console logs, browser metrics, etc., to identify various UX bugs such as performance issues, visual issues, accessibility, layout, and usability, etc. And it will attribute those bugs that is found to the relevant screen states, giving you the visibility that you saw earlier on the Atlas page. And lastly, for your web tests, TestChimp enables intent steps in your scripts itself, via ai.act and ai.verify commands. This removes the UI selector based brittleness that is common with pure playwright scripts. And unlike typical agentic test solutions, which require all steps to be in plain English, our approach enables you to have most of your test be script based but include intent based steps only for the portions where the product is a little bit flaky or it is harder to author using UI selector based approaches. So to recap, TestChimp essentially orchestrates a workflow that drives your coding agents to monitor coverage gaps aligned with your requirements as well as real user behavior and expand coverage continuously as your product evolves.